This is a mini bite for rates of reaction linked to the C3 OCR Gateway GCSE unit. Collision theory is about how particles need to collide in order to allow a reaction to actually happen. A successful collision results in a chemical reaction occurring and the new product being made. Collisions between particles need to have enough energy. If a collision between two particles is not high in energy, then they will just bounce off and lose some of their own energy. If a collision between particles, however, has sufficient enough energy for them to react and they collide together, then a chemical reaction will happen and a new product will be made. There are certain conditions that can affect how quickly a chemical reaction will happen, what we call rate. Things like increasing or decreasing temperature can have effect on the reactants that are reacting together. Just like changing the surface area of a solid reactant and the concentration of reactants in solution. Let's start with concentration. Concentration can increase or decrease rate of reaction. If you take the two boxes on the screen, let's say we have a solution. It's the same solution but of two different concentrations. These boxes represent a certain volume, the same volume. It could be 10 centimeters cubed or 10 milliliters. The blue dots represent the particles, the reactant particles that are present in that particular solution. If we compare both of the boxes, you start to notice a difference between the two of them. The box on the left has more reactant particles compared to the box on the right hand side. The box on the left is a high concentration, where you have lots of reactant particles in a particular volume. If you compare that to the box on the right, we have a low concentration. There are far fewer reactant particles present in that particular volume. So increasing or decreasing concentration will change how many particles are there. Rate and reactions are about collisions. So if we increase the concentration, we are going to have more particles present. So how does that affect the number of collisions that could happen? Well, if there's a high concentration and if there are more particles present, you would automatically think there would be more collisions. And that's correct. However, in exams, this would give you the ability to only get up to a C grade answer. There's got to be something else, because what does more collisions really mean? If I told you there had been 1 billion collisions, would you think that reaction was a fast or a slow reaction? Most people would probably think it was going to be quite an increased rate of reaction. If I said those 1 billion collisions had been taking part over a period of time like 10 years, some of you may change your answer and think it was quite slow. If, however, I had said that the 1 billion collisions had taken part over 10 seconds, that would change your perception and you might think it was quite a fast reaction. So to get the higher grade, you can't just talk about there being an increase in the number of collisions. If you change what you are talking about to talk about a time frame, for example, more collisions per second, this gives you the ability to access the B and the A grade answers. Another way of expressing this would be talking about there being a higher frequency of collision. Temperature also affects how quickly a reaction will occur. And there are two key things that changing temperature actually affects. The first one is that changing temperature can affect the energy that's actually there. Increasing temperature will give the particles more energy, whilst reducing the temperature will mean that the particles have less energy. The other effect that changing temperature can have, because of the amount of energy that can be given to the particles, is that it can affect the collisions. And again, this is an important element when it comes to talking about rate of reaction. Temperature can affect energy and number of collisions. If we increase the temperature, we are going to give those particles far more energy. That's going to increase the number of successful collisions that can happen. Remember, a successful collision is a collision that will result in a chemical reaction when they collide. Lots of collisions result in nothing. So giving them more energy makes them more likely to react. In addition, you're going to increase your collisions because of the fact that they have more energy and are so moving much more quickly. Again, it's important to bring the time element in and to ensure that you put per second to give a context to how many collisions there actually are. If we have a solid involved in a chemical reaction, surface area can play an important role. In the example that's on the screen, we have a solid that will be reacted with a solution. And at this moment in time, the only surface area that is available for the reaction is around this area here. That means the particles on the outside of the solid will be able to react, but the particles inside the solid here do not have the ability to. If we break or crush our solid into pieces, we actually change the surface area available for the reaction. So let's say we take our solid and we break it down into 4 pieces. We now have our reactant crushed, but the most important part is to see how the surface area has been changed. Originally we had only this outside area where the particles were available for the reaction. We still have that outside area here, but now we have the particles on the inside, there, and there, and there, that now are available. So what we've actually technically done is we have increased the number of particles that are present. So increasing surface area is a little bit like increasing concentration. What you have is more particles that are exposed. Those particles have the ability to actually change the rate by again affecting the number of collisions that we have. If we have more particles exposed on the surface of our solid reactant, we are going to get more collisions. And again, to gain access to the higher marks, we are going to make sure we include time. So more collisions per second would be created with a larger surface area. Now, one factor that we didn't talk about right at the start is the use of catalysts. In Unit C2, you look at the use of iron as a catalyst in the Haber process. Catalysts do something incredibly important. Catalysts have the ability to speed up rate. However, catalysts also have other uses because of how they get involved in the chemical reaction. So how do catalysts actually help to increase rate of reaction and in industry help to reduce energy costs? In the case of reactants, in particular solid reactants, one of the most useful aspects of using, for example, iron in the Haber process to make ammonia is the fact that you have iron at the start of your reaction and you have iron at the end of your reaction. So it almost looks like the catalyst isn't actually participating in the chemical reaction at all. Technically, that's not true. And if you go on to A-level chemistry, you'll learn more about solid catalysts and how they actually work. But at this stage, it's important to realise that a catalyst, in particular a solid catalyst, acts as a surface, and it allows the reactants to basically stick to the surface. What that gives the reactants the ability to do is to get close. And in getting close, you're able to increase the number of collisions that can happen, guess what, per second. Again, a very, very important part to include in all of your answers about rate.